All right.
It's kind of hard to see with
The light's on, yeah. All right, so today's date is Tuesday, January 28th, 2020. We are on lesson 7-4, simplifying square roots. Tomorrow is 7-5, simplifying square roots with variables. Who wants to read our objective for today? Emma was first.
Remove perfect squares from inside square roots.
There it is, thank you. All right, so I'm teaching you two different methods. The first of the two methods, and again, you get to choose whichever one you want. I will never force you to do a method unless I really, really think it's important. These two methods are kind of equivalent, so choose your favorite. Procedure. You're going to factor out as many, and you can kind of read the objective and answer this question. Factor out as many what as possible. Wyatt?
perfect squares.
Perfect squares, yes. So I don't have room for perfect squares, so I'm just going to say squares. Squares and perfect squares mean the same thing. So, do you guys know what a square is? Ready? 1 times 1 is 1. That's a perfect square. 2 times 2 is 4. 4 is a perfect square. All of your perfect squares up to 25 squared are up on this list. I'm never going to go above that, so there's your poster. I also have perfect squares up to 10 on the back corner. It says perfect squares. It goes 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Those are the perfect squares that you're going to be looking for most often, but again, sometimes I go off of that list, but those are your visual way of comparing squares to cubes.
Wait, what 72 are perfect squares?
72. That's a good point. So how are we going to do this? Does everyone, can you repeat what you just said, Charles?
Factor. Oh, yeah. Oh, 72 and 80 are perfect squares.
Yeah. Those aren't on the list, so how are we going to proceed? And the general idea is I'm going to give you any number, 100. Oh, that's easy. 102. I'm going to give you some random number, and you have to look for perfect squares that are the factors. And by factors, I mean they're in that factor tree. So, think of a factor tree of 80. Your factor tree is going to look a little bit different because it has a square root. So instead of saying 8 and 10, I'm going to say square root of 8, square root of 10. But that's bad to begin with because neither of those were perfect squares. So this first method, I'm looking for one of these factors to be a perfect square. Does anyone see one of those perfect squares or one of those perfect squares on my walls that goes into 80 with a quiet raised hand? You have your card turned in, you have your card turned in, you have your card turned in too, Larissa, because you did the warm-up. Kira, you kind of did the ruler, but no, okay, let's go with Kira, yeah.
Okay. Well, I don't know if this is right at all. Could you do 4 times 20?
4 and 20, yeah, because 4 is a perfect square. So we're kind of done. Once you hit a perfect square, that kind of kills the branch, and you don't really think about it. You can circle it, you can box it, I don't know. Whatever method that you want to say, hey, I'm done, perfect square, but I need to keep going with 20 if you think there are any perfect squares, and I'll give you the hint, there's at least one more perfect square inside of 20. So another quiet raised hand. That is a good point. So there's something called the fundamental theorem of algebra that says I don't actually know exactly what it says, but it basically says a number can be factored into unique primes. And in order to not break that theorem, I cannot say this. 80 is equal to 80 times 1, which is unique, which is 80 times 1 times 1. Well, aren't those the same thing? It kind of breaks the fundamental theorem of algebra, so we don't think of 1 in the factor tree because you'll break the fundamental theorem of algebra, and this is an algebra class. That sounds like it's an important rule, and it is. So unfortunately, we cannot use 1, but that's a good point to bring up, Charles.
We're going to break that rule now that you've taught us it.
I know. Rules are meant to be broken, right, Anna? Asha, yes.
Well, you could do another square root of 4.
Oh, yeah, and
5.
5, yeah. And we're done. There is your finding the squares method, and we can now say that 80, or the square root of 80 rather, is equal to, and it's kind of all the ends of the branches, right? So it's the square root of 4 times the square root of 4 times the square root of 5, and hey, you guys, I already taught you last lesson what the square root of 4 is, and hopefully you know the square root of 4. And a bunch of the other ones you should know. What is the square root of, 484 as well. But what is the square root of 4 times the square root of 4 times the square root of 5? Getting rid of as many of these radical symbols as possible. Do you have your card still, Charles? Okay. Does anyone still have their card? Square root of 4. You guys got this. Square root of 4.
Yeah,
You do? Okay, go for it, Charles.
So the square root of 4 is 2, so it would be 2 times 2, which is 4. times the square root of 5.
Yeah, 4 square root of 5. And that's how you simplify that radical. The final answer is 4 square root of 5. And there's actually a shortcut. If you're really, really wanting to save some time, you could have thought of 80, and the reason I chose 80 is because you can do it a few different ways. I could have thought about this factor tree, let's do a factor tree that comes out to the left, as 16 and 5. And 16 is a perfect square, and I would have been done immediately. 16 square root of 16 is 4. I get the same answer, it's 4 square root of 5. So your factor trees will lead you in maybe different paths, but hopefully to the same solution. Let's try another one. Let's try the square root of 72. Does anyone see, I should leave this on the board otherwise I'm going to forget it. Does anyone see any perfect square that goes into 72? I see one hand.
What?
It's kind of hard, right? What on that list? And typically speaking, I'm not going to give you anything too big. I very, very rarely will give you something that has 49 in it. Everything's going to be less than 49. Yeah, Jade.
9?
9. Yeah, so 9 and what?
9 and 8.
And the square root of 8. Perfect. Square root of 9 and the square root of 8. Okay, square root of 9, that's a perfect square, so we're kind of circling that guy. We're done. But square root of 8, and this is the hard question. And this is the most difficult part with factor trees and finding how to simplify square roots. In my opinion, the hardest part is knowing when to stop. Like, are there any more perfect squares? And it just comes from experience. So there's no right answer like, oh, just do this and you'll know. So you don't know. But this one does have at least one. Does anyone see another perfect square inside of 8? Does anyone have their card still? Ulysses?
Yeah.
Yeah, go for it.
Would it be 4?
Yeah, 4 and 2. And we kind of have to stop there because 2 doesn't have any more perfect squares. So we kind of say this is now equal to square root of 9 times the square root of 4
Or you can also do this
times.
I mean, you could also, you could also divide the 4 again into 2
Into 2 and 2. So you're correct that we could continue the factor, but we want to stop as soon as we find one of these squares, which is the same reason that we didn't keep going with the 9 into 3 and 3, the same reason that we didn't continue with these 4s into 2 and 2s. So we want to stop when we hit a perfect square. But you, Emma, and Eamon are both correct that we could have kept going, and that is the second method that I'm going to be going over. So if you like that second method, you want to continue the whole factor tree, then you can do that with that other method. Yeah, Kira.
How do you know if a number is a perfect square?
It is on that list.
Got it.
Yes.
On the left.
So 1 is a perfect square, which we're not going to be using. 4, 9, 16, 25, 36, 49, 64, 81, 100. All of that list is a perfect square. Another way of answering that is a number times itself is always a perfect square, but it's harder to see. Just try memorizing the list.
Like 1, 4, 9, 16. Those?
Yep, those are all the squares that you're looking for. All right, and I need someone to finally simplify our answer. Why you've been waiting very patiently.
Thank you.
Oh.
Sorry. So the square root of 9 and the square root of 4, that'd be 3 times 2 times the square root of 2. So 3 times 2 is 6, so it would be 6 square root 2.
Beautiful, there it is. And we box it. And again, there was another way of doing this. We could have said 72 is 36 times 2. And then we would have stopped at 36, and 36 turns into 6, right? All right, so that is my personal favorite way of doing it because it uses a little bit more logic. It's a little bit quicker, but it's harder because you don't know when to stop. The next method is a sure true method, but when I teach this method, people will randomly do the procedure not knowing the real mathematics of what they're doing. So now you understand what we're really trying to do for the goal. This one is just if you do this method every single time, you'll get the right answer, but you might not know why you're getting the right answer. So complete the entire complete factor tree method. So you're going to make a factor tree and find, I guess it should be, as Eamon said, the blank of a blank factors, or of a factors. Find, and it's a word that starts with P here. I'm looking for something that means 2.
Pair?
Yeah, pair. And I should be looking for quiet raised hands next time, but that's okay. Next time. Find a pair of factors. So if you find the pair of factors, then you're good. And you might be wondering, well, what do you mean by that? Well, first, let's make the factor tree. So we're going to have to conserve room here because our factor tree is going to be a little bit bigger than we had before. I try to give us a little bit more room. All right, I need a quiet raised hand to do the entire factor tree. Is there anyone that hasn't participated yet? Is everyone in? Ugo, you want to do the entire factor tree? Let's do it. 80, go.
Can you do the 4 and 20?
Yeah, let's do 4 and 20. So square root of 4, square root of 20, keep going. And then this 4, I'm not done with him yet, right?
Oh, nice.
Keep going, Ugo.
2 and 2.
Perfect, square root of 2, square root of 2. And 20, Ugo, is what and what?
4 and 5.
Perfect. So I'm going to do 5 and then 4, just so that I have more room on the right-hand side. And then 4, Ugo, is
2 and 2.
2 and 2. Thank you, Ugo. All right, I'll take your card.
Oh, we're not gonna do it in 5 as well.
So you can't, 5 can't go any further because it would be 5 and 1. So whenever I hit 1, I'm just kind of stuck.
Oh, wait, yeah.
And then we kind of circle pairs now. So if you ever see 2 of the same number, we're going to circle those together. So it doesn't make too much sense to do this. It would be really weird to do those and then these because they're so far apart. But you could. I'm just going to go pair right there, and then I don't really have a pair for the 5, so I can put a different symbol around him. I can put like maybe a square instead. A square around all the ones that don't have any friends.
What about the 4s, though?
So the 4s, I'm only looking at the ends of the tree, the very tips of the tree. So this is like an upside down tree where this is the tree, and then this is like the top of the tree. Does everyone see the inverted tree? Yeah, so I'm going to look at the tops, the end of the trees. All right, and then whenever you see a pair, that pair turns into just 2. So this pair of square root of 2s, that's going to be just 2. This pair of square root of 2s is just 2. You kind of, whenever you see a pair, you eliminate 1 and circle 1. You eliminate 1 and circle 1. I don't know the best way to explain this aside from whenever you see a pair, it turns into just a normal 2 because the square root of 2 times the square root of 2, a little bit of the reasoning here, is the square root of 2 quantity squared. And whenever I have a square root and a square root, they cancel each other out. So that's why I'm left with just 2, like I have down here.
So if it was like 4 and 4, it would just be 4.
Exactly, yeah.
Okay.
And then you get the same answer that we had before. You say, okay, now I have, come over here and you can say I have 2 times square root of 5. You have to leave that square root of 5, and then that turns into 4 square root of 5. So it's very, very similar to the last method. And the nice thing about this method also is I don't have to keep putting square roots on here. It might start getting confusing if you don't do that. I like leaving the square roots in my factor tree because I know what it means. But if you want to start skipping steps using this method, it's okay. The other method, I don't recommend it at all. This method, it's okay. For example, 72. Let's go ahead and do this without any square roots, and I'll show you that it still works as long as you stick to the procedure. Another quiet raised hand. I think everyone is in, right? So we can just do rapid fire. Oh, no, Hazi. All right. 72, go. What times what is 72?
9 times 8.
9 times 8. And what is 9?
3 times
3 times 3. And then 8 is
4 times 2.
4 times 2. And then 4 is
2 times 2.
2 times 2. Perfect. Thank you. And then from here, we're circling all of the pairs. So I have a pair of 3s. I have a pair of 2s. And I have one left over 2. So the answer here is whenever there's a pair, you just turn that into 1. So this is going to be 3 times 2 times, and whenever I have a single number, that single number is always going to be a square root. So times the square root of 2, and that turns into 6 square root of 2. Just like we had up above. You can compare the answers. 4 square root of 5, 6 square root of 2. You see both of the different procedures. The nice thing about the complete factor tree method, the second method, is if you don't know what perfect squares are, or you don't know when to stop, this will always work. So if you don't like memorizing your perfect squares, this is the method for you. If you want to be a little bit faster with your mathematics, you can come up here. So it's kind of a speed versus consistency thing, I suppose. All right, so you're going to choose whichever method that you want. I want you guys now to try your technique on example 1. Maybe try one of each, see which one feels better. Maybe you already know which method is going to feel better. Try simplifying square root of 96 and square root of 125. I'll come back and I'll just circle around the room to see if you guys need help. Good luck. If you finish example 1, that was too easy, you can go to example 2. And after example 2, you can start on the homework.
Wait.
It is not. It's a cube.
Oh.
Yeah, but not a square. All right. Is there a volunteer for example number 1 to do the square root of 96? Ashley, go for it. I'm gonna make sure you're doing homework.
Oh, do you want me to?
Oh, yeah. If you could just call it out, I can write it down really quickly.
Okay. Like every step.
Yeah. Just tell me the factor for 96 and then what it turns into.
Okay. I got 2 and 48, and for 48 I did 6 and 8. For 6 I did 3 and 2. For 8 I did 4 and 2. For 4 I got 2, 2, and I paired the 4 2s together.
So you did those 2s,
Yeah.
those 2s.
And then I, got the 3 and the 2. And then I ended up with 2 times 2 times the square root of 3 times the square root of 2 is 4 times the square root of 3 times the square root of 2, and you just times the 2 square roots, and I got 4 to the square root of 6.
Beautiful. Thank you. Yes. 4 square root of 6 is the final answer. Make sure that everyone is checking their work. For example 1, if you have not already checked with me, 4 square root of 6. All right. What about for the square root of 125? Does anyone want to walk me through how to do that one? Charles?
So there you have 125, that is the same as 5 times 25. And that is 35, so it's 5 squared and 5.
Oh yeah, perfect. So you kind of did the first method where you have these both square rooted, and this is just equal to square root of 25 times the square root of 5, knowing that this is a perfect square. And you said 5 square root of 5, right? 5 square root of 5. Perfect. Thank you. And then, for example 2, who wants to do square root of 8 for us? Jade.
Okay, I got 2 times 4 and 2 and 5.
4 is 2 and 2. All right.
And then
Yeah.
2 square root of
2 square root of what?
2.
Perfect. Yep. 2 square root of 2. And 108. Charles, you want to go again?
3 and 36.
3 and
36 is perfect square, so 6 square root of 3.
Very nice. That one was really hard to see. And there's our final answer. Cool. That concludes our notes 7-4.